Okay, so we'll solve one important problem. The problem is given in CSIR NET December 2023. It is given from the abstract algebra, and if we think about the relation and function, and also you can say this problem is taken from real analysis. No problem. You can say it comes from abstract algebra or real analysis. Now, first we recall some basic facts. So, what are the basic facts? The first fact is when f is called injective. If it is a function from R to R is called injective. If and only if x equals to fy, that implies x equals to y for all xy belongs to r. Or you can show x not equals to y implies fx not equals to fy for all xy belongs to r. So this is for injectiveness. And when we call the function f is surjective, if f of r equals to r, that means we can say the range of f, this is exactly the codomain. This also tells us the function is surjective. Or if f is continuous function and monotone, that means either monotone increasing or decreasing. Say your function is basically minus infinity if r to r, it is either monotone increasing or monotone decreasing or monotone decreasing. And in the both cases, if either limit extended to infinity fx equals to infinity and limit extended to minus infinity equals to minus infinity, or if extended to infinity fx equals to minus infinity and limit extended to minus infinity fx equals to infinity. That means it is unbounded on the both sides. Okay. So in that case, we can say f is surjective, or that means f r equals to r. So that means the range of f equals to the codomain, and I conclude that f is surjective. Now we come to the problem. So first we assume that, say, we are showing this function, what is exactly given? It is given fx minus fy, that is greater than equals to logarithm of 1 plus mod x minus y for all xy belongs to r. Now, if possible, let we just try to prove with the help of this condition. Let x comma y belongs to r be such that here f is r to r. So for injectiveness, be such that fx equals to fy. So if fx equals to fy, then we can say mod of fx minus fy, that value must be 0. And from this equation, from this relation 1, that implies logarithm of 1 plus mod x minus y, this value less than equals to 0. So this is our single star. Now what we have, we can write 1 plus mod of x minus y. This is greater than equals to 1 for all xy belongs to r. Why? Because since modulus of any number is always greater than equals to 0. And from that case, we can apply the logarithm 1 plus 1 minus 1 plus mod of x minus y, that value greater than equals to logarithm of 1. Because you know, log is also injective function. So if a greater than equals to b, if a or b are positive number and a greater than b, that implies logarithm of a must be logarithm of b. So from that we can write log of 1 plus mod x minus y, that value greater than equals to. This is double star. So from single star and double star we can prove that logarithm of 1 plus mod x minus y, this value here, it is greater than and also less than equals to 0. So that means this value equals to 0. So When the logarithm of this value equals to 0, so that means 1 plus mod of x minus y, this is equals to 1. Why? Since log of 1 equals to 0 and logarithm function log x is greater than 0 is an injective function. That we know. And from that case, mod of x minus y equals to 0. And we know the modulus of a number, if mod alpha equals to 0 and alpha is a real number, that condition holds if and only if alpha equals to 0. So that means x equals to y. So what we get? We get if fx equals to fy, then it implies x equals to y for all xy belongs to R. So that means the function f R to R is injective. So 1 function. Okay. So from that we can conclude f is 1 1, f is not 1 1, not 1 1 is there. So this option is discarded. Here f is neither 1 1, that means this option is discarded. Now we have to prove f is surjective or not. So how we will prove f is surjective? That will come to this point. For surjectiveness and f is continuous, we will show just f is monotone and limit extending to infinity and limit extending to minus infinity. That value is basically 1. So what we will do? So for surjectiveness, now we claim that our next claim. So if this f R to R is surjective where f of x minus fy, that modulus is greater than equals to logarithm of 1 plus mod of x minus y for all xy belongs to R. Okay. So this we have to prove. So here first it is given f is continuous. Okay. So our information f is continuous from R to R. This information is given. Second, what we will do, we'll take say x minus y equals to h. So let x or y both are real number be such that h equals to mod of x minus y and mod of x minus y. So without loss of generality, we assume that x is greater than y. You can think about x is less than y. So here we assume this is your real line. So here x and this is your y. X is greater than y, that means this is your x and this is your y. So in that case x minus y, that modulus will be mod of x minus y, and this is basically our h, and h is also greater than 0. So again we have the relation fx minus fy, that modulus greater than equals to logarithm of 1 plus mod x minus y. This relation holds for all xy with x greater than y. Now we divide for all xy belongs to R because we assume here x greater than y. That's why we have written x greater than y. So now we'll divide by mod of x minus y on the both sides. So what we will get? We will get mod of fx minus fy by mod x minus y. This is greater than equals to log of 1 plus mod x minus y by mod x minus y. Now we have taken x minus y equals to h. So that means our x equals to y plus h. So, or you can say, okay, we'll write here. So that will be f of y plus h minus fy by h. This value is greater than equals to log of 1 plus h. We have taken the modulus 1 plus h by h. We have taken mod of x minus y equals to h. So h is greater than 0. So just we apply limit h tending to 0. H tending to 0, f of y plus h minus fy by h. This is greater than equal limit h tending to 0 log of 1 plus h by h. So that means we can write here, just we replace y by x, we can write limit h tending to 0. If we take y equals to a is basically real number. So limit h tending to 0, or you can take y equals to x, no problem. F of x plus h minus fx by h. This is greater than equals to, this limit you know, this limit is basically 1. So that means here f dash x, this is basically f dash x, by the first principle of the derivative. This is greater than 1, and that part is greater than 0 for all x belongs to 1. So that means f is strictly monotone increasing. Similarly, if we take here x less than y, then f will be strictly monotone decreasing. So on that case, because on that case you will get f dash x, that modulus greater than equals to 1. So that means it will be either greater than 1 or less than minus 1. In that case, f is decreasing, and in that case, f is increasing. So f is a monotone function. F is monotone function. Now we'll calculate limit. Now here you will find limit extending to infinity fx and we will check that will be infinity. You will check it easily. And limit extending to minus infinity fx, that will be minus infinity. You'll check it. So since f is continuous monotone function, and limit extending to minus infinity fx equals to minus infinity, limit extending to infinity fx equals to infinity. That means it is bounded on the both sides. How we will show? Just I will give you a hints. You will take limit extending to infinity. Take y equals to some number. Say y equals to 0. So on that case, what will be your relation? Fx minus f0. This modulus will be greater than equal log of 1 plus mod of x minus 0. And if we take limit extending to infinity, so mod of fx minus f0, that will be greater than equals to limit extending to infinity log of 1 plus mod x. So this will be limit extending to infinity fx, that modulus, and that is basically a constant. It is greater than or equals to f0 plus here logarithm of limit extending to infinity 1 plus mod x, and that will be basically infinity. And from that case you can conclude this result. So that means f is surjective function, or you can say f of r equals to r. So here we conclude that f is injective as well as surjective. That means f is bijective function. So f is both 1, 1 and 1, 2 are correct, and all other options are false. Thank you so much.